Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to introduce the concept of externalities. Up until this point we have been thinking about idealized markets that are perfectly competitive and have no effect on bystanders. These markets are going to be efficient when left to operate on their own with no government interference. Government policy such as taxes tends to result in a loss of efficiency in those markets. We are now going to examine some markets where the free market fails to allocate resources efficiently. We'll talk about what kind of conditions can lead to market failure and what the government can do about that. An externality is an impact of one person's actions, typically in a market, on the well-being of a bystander. Externalities can be negative or positive, and both of those types lead to a market failure. The reason this is a market failure is that the buyers and sellers in the market do not take into account the effect on the bystander, they only think about the benefit or cost to themselves. When they make a decision, they are only considering the private benefit or cost to themselves and not the overall cost or benefit to society. If bystanders are affected, the consumer and producer surplus of those buyers and sellers within the market is no longer sufficient to think about the total welfare due to a market. In a market with an externality, the total surplus for the buyers and sellers who chose to be in the market is still maximized, but society's welfare is not maximized. Recall that the supply curve tells us the cost to the marginal seller in the market. This cost, though, is just the private cost to the seller. It does not take into account the overall cost to society. On the other side, the demand curve tells us the value of the good for the marginal buyer. And again, this is the private value, the value that that individual buyer gets from the good. It does not take into account society's value for the good. When private cost does not match up with social cost, there's going to be an externality, and likewise, if private value does not match up with social value, there's also going to be an externality, and both of these are going to result in a market failure. When social cost exceeds private cost, we have a negative externality. When social value exceeds private value, we have a positive externality. Let's consider negative externalities first. We're going to return to our supply and demand curves that we've been working with up to this point. QD equals 50 minus 5p, and QS equals negative 10 plus 5p. I've drawn these out on the graph to the left. Let's suppose this supply and demand curve are for cigarettes. Cigarettes have a negative externality because they have a negative impact on bystanders in the form of secondhand smoke and the health risks associated with that. In the case of cigarettes, since the sellers are only taking into account the private cost to produce the cigarettes and not the cost to bystanders, we're going to have a market failure. Suppose that each cigarette imposes an external cost on bystanders of 2. We call this an external cost because it is a cost borne by other people who did not choose to be in the market. We now need to incorporate the external cost into the supply curve, which is our private cost, to figure out the total social cost for the good. Let's see how this looks on the graph first. For any given point on our private cost or supply curve, we now need to add 2 to the price to reflect this external cost. So I'm going to take all the points along our supply curve and move them up by 2. Connecting those up, we have our social cost curve. At every point, it is 2 higher than the private cost, reflecting the external cost. We can now compare the private equilibrium, which has a price of 6 and a quantity of 20, to the socially efficient point, which has a price of 7 and a quantity of 15. What this tells us is that the private equilibrium has too high a quantity relative to what society would want. In our example, that means that more cigarettes are smoked than society would prefer. This makes the private equilibrium inefficient compared to the socially efficient one. To do this algebraically, I'm going to write QSC for social cost, -10 plus 5, and instead of P, we are going to write inside parentheses P minus 2. We're subtracting 2 here to reflect the external cost to society. Thinking about this intuitively, the suppliers receive a benefit of P for every unit they sell, but for society this is actually 2 lower because of that external cost. Multiplying this out, we have -10 plus 5P minus 10, and so that's going to come out to -20 plus 5P. To figure out the socially efficient price and quantity, we set that equal to the demand and then solve. I'm going to add 5P to both sides, and then add 20 to both sides, and then divide by 10. That's going to give me P equals 7, which is exactly what we saw on the graph. We can then plug that 7 into either our demand curve or our social cost supply curve to get our quantity equals -20 plus 5 times 7, which is 15. And that shows up right here on the graph. I'm going to put SE for socially efficient on both of these. We've again shown that when there's a negative externality, the private market ends up with a higher quantity than the socially efficient quantity, meaning that the market failed to allocate resources efficiently. Since the market fails to allocate resources efficiently, it falls to the government to do something about this. We call this internalizing the externality. The government needs to adjust the incentives of the sellers so that the private cost matches up with the social cost. We already have something in our toolbox that we've learned about already to do this, and that is an excise tax. If we impose a tax on the sellers of 2 per unit, that's going to force the sellers to take into account the social cost. And the tax wedge of 2 will force the quantity in the market down to 15, which is exactly where we wanted it. If we think about cigarettes, this is quite common in real life. For example, in South Dakota, there is a $1.53 per pack tax on cigarettes. It's important to note here that a tax on an externality is a tax that actually increases social efficiency rather than decreasing it, like we've seen before. A tax on a negative externality does not incur a deadweight loss, and in fact does the opposite. This gives the government an opportunity to raise revenue while also benefiting society as a whole. Let's talk about a few more examples of negative externalities. One of the most important negative externalities that we see is pollution. This could be air pollution, water pollution, and so on. Industrial production of all sorts of different goods results in lots of different types of pollution and emissions, and the cost of pollution tends to be borne by society as a whole, as opposed to the individual company that is doing that pollution. One specific example we can look at are automobiles. Your main private cost of operating your car is whatever you pay for gasoline. The external cost is the air pollution that comes from the exhaust from your car. You don't pay for that individually, we all pay for that as a society. The way the government can internalize this externality is by putting a tax on gas. This puts the cost to the individual driver in line with the cost that they are incurring on society. If gasoline is more expensive, people are going to drive less and there's going to be less pollution. Let's think about one more example, which is a house party. The cost of having a big house party in a college town is going to include the food and drinks that are served to the guests, but there is an external cost to the neighbors, which is the noise. But it doesn't make very much sense for the government to put a tax on partying, and so instead we have noise ordinances. The way this cost is internalized is the risk of having the police come and shutting down the party. That threat helps bring the private cost in line with the social cost. We are now going to move on to positive externalities. A positive externality exists when an external benefit makes the social value exceed the private value. A classic example of a positive externality is education. Think about the degree that you are working towards, There's a private benefit to getting that degree, which is the increased job opportunities, skills, and knowledge that you're getting out of it. And those are the kind of things that you would focus on when trying to decide whether it's worth it to get the degree. But being educated also confers a positive benefit on everyone else. A society with more educated people is going to benefit from more educated voters and higher productivity. But when a person is deciding whether or not to go to college, they're not thinking about those potential benefits to everyone else. They're thinking about what they are going to get out of it. We're now going to consider our supply and demand curves from before as a market for education. We'll think about the quantity here as years of education. Suppose that each year of education that people get gives an external benefit of 2 to society. To graph this out, we are going to take our demand curve, or private value curve, and move it up by 2 at every point along the graph. Connecting those up, we have our social value curve. It sits 2 higher than the private value. We can now compare our private equilibrium, which had a price of 6 and quantity of 20, with the socially efficient price of 7 and quantity of 25. What we get here is the opposite of what happened with a negative externality. Here, our private equilibrium quantity of 20 is too low relative to what society prefers. To do this algebraically, we need to incorporate our external benefit into the demand curve to create our social value curve. I'm going to write QSV for social value. We'll take 50 minus 5, and inside the parentheses, this time we are going to take P minus 2. The intuition behind subtracting 2 here is that our private consumers are not taking into account that external benefit of 2, so you can think of society getting a discount of 2 for every unit of education relative to what is privately being paid. Multiplying this out, we have 50 minus 5p plus 10, which is going to leave us with 60 minus 5p. To figure out the socially efficient price and quantity, we set that equal to our supply curve and solve. I'm going to add 10 to both sides and add 5p to both sides, which is going to give us 70 equals 10p, and then we just need to divide both sides by 10 to get p equals 7. I'm going to label this with an SE for socially efficient, just like we did before. We can then take the 7 and plug it into either our social value or supply curve. We'll plug it into the social value curve to get the socially efficient quantity of 60 minus 5 times 7, which is going to be 25. These values match up with what we see on our graph. So we again see that when there is a positive externality, the private market ends up with too low of a quantity. That's going to be inefficient. So how can the government solve this? With a negative externality, we used a tax to reduce the quantity, but this time we want to actually increase the quantity. In effect, what we need to do is a reverse tax, which is called a subsidy. A subsidy is where the government helps pay for a good. This encourages more people to buy the good. In our example, if the government gave each student a payment of 2 for every year of education they pursue, then that's going to push the private value curve in line with the social value curve. That's right in line with thinking about this minus 2 right here as a discount that the government would need to help provide. The federal government in the US accomplishes this through Pell Grants, which help students pay for college. Other countries do even more than that. Let's think about one more example of positive externalities, and that is technological spillovers. When a technological innovation happens, the innovator only gets a part of the total benefit. For example, if a company comes up with a new innovation that results in cost saving in production, that's going to be a private benefit. But at the same time, that innovation is going to enter into society's pool of knowledge for others to benefit from. Others who did not contribute to the technological innovation and therefore did not have to pay for it. That's a bystander benefit, or a positive externality. Since the innovator is unable to reap all of the benefits that society gets from an innovation, the private value is lower than the social value. This results in too little technological innovation being done. So how can the government solve this problem? There are a few ways to do this. First, the government could simply subsidize research, just like we saw with subsidizing education. In the US, this does happen with grants to university researchers and also tax breaks to companies that engage in research. The government can also help the original innovator capture more of the total benefit with patents. A patent gives an innovator exclusive rights over the innovation for a limited period of time. In the United States, this is typically 20 years for a utility patent. This can lead to market power, which is another problem we'll discuss later on, but are still an important tool to incentivize innovation. They are particularly important in the pharmaceutical and semiconductor industries. In the next video, we will go over some more strategies the government can use to deal with externalities.